Another project that I'd started literally years ago and never quite finished, and put on the back burner, and frankly I've forgotten what state it's in. Anyway, this is an Aiwa AD-F640. This was the first piece of hi-fi I ever bought, so it's got a soft spot in my heart, as it were. So when was this? I want to say about 87 or something I bought it, maybe 86, something, I don't know, something like that. So very expensive for me as a young boy, but yeah, I saved up, and I had a choice of, I think it was like the AD-F 550, which was an auto reverse deck, or this one, which was 3-head dual capstan, but potentially better quality. I went for this one. So it's got Dolby BC, HX Pro, as I say, 3 heads and dual capstan, adjustable bias on normal and chrome, not metal, interestingly. Got an MPX filter, although not particularly useful. That was used for old tuners that had very poor suppression of the pilot tone, the 19 kilohertz pilot tone. So that basically is a filter. But I never needed that. Anyway, used it to tape stuff off the radio with my dad's tuner until I got my second piece of equipment, which was my own tuner, the Pioneer. There's a video about that. So, well, what to tell you about this? While this was still under guarantee, it developed a fault. Classic fault. Well, not classic, but I mean, interesting fault. The logic control system, after a little while, a few minutes maybe, would go haywire. It would sort of flash different things. Occasionally, while you were rewinding, it would suddenly go into record mode or something, and just basically playing up and become unusable. This was intermittent. We took it back. I remember my dad driving us back to the shop, and there was a repair service centre at the hi-fi shop. I think it might have been in Preston. And they had a look at it and had it on soak for a week or two and couldn't find any problems. Brought it back. As soon as I used it for a few days, it would come back. The problem would come back. So we did this a couple of times. Still no joy. So one of those annoying intermittent faults. Anyway, I found out after, I don't know, a few weeks, a couple of months or something, that it was temperature sensitive. So if I was to heat up the base gently of this deck, it would become much more reliable and not exhibit this problem. So that was interesting. Anyway, my dad got some freezer spray, and he helped diagnose the problem. And it turned out to be, if you look from this angle, this is the microprocessor, the microcontroller, as we'd call it, and then an oscillator coil here to generate its clock. This would be sensitive to temperature. Freezing it, getting colder, would stop the system working. Anyway, my dad took this coil apart, filed the case down so he could open it, and found a tiny microscopic bead of solder. You know, those little beads that sometimes form, like they kind of spring off, bubble off almost the thing you're soldering, and just sort of lurk around. Well, that was just in between one of the legs of the transformer and its case. So once we'd removed that, well, no more problem. So it must have been just temperature sensitive, you know, expanding, contracting, a fraction of a millimeter, either shorting or not shorting the oscillator coil, and therefore the logic control system was going haywire. So that was a very interesting fault that I'll never forget. We spent a lot of time trying to diagnose. The other interesting thing is that I bought this based on many reviews and seeing it in the shop. And as I say, this was my first bit of equipment, so I had to use it on headphones. I'd got a pair of COS headphones. I think they were fairly unimpressive, but it was what I had at the time. And as soon as when I got it home and unpacked, I suddenly realised, hold on, where's the headphone volume? I mean, we've got a nice headphone socket here. Normally, there's a headphone volume control next to the socket, right? You'll notice there is none, and in fact, there is none, which is really weird. It's not like there's lacking of space here to put it on. I mean, it's just crazy just not to design one. So for a long time, I mean, I had to just not have any control over the headphone volume. I did build a board, and recently, now I've learnt KiCad, I've built my own circuit board, a little bit neater than the Varistrip that I was using. So I've just taken out the coupling capacitors and a couple of resistors and broken them out, and put a volume control in there, just between the line coming out and before it goes into the headphone amplifier here, and then this takes the signal back to the socket on the front. So that just allows you to cope with different sensitivities of headphones mainly, and different source volumes, of course. Okay, so I mean, that's a couple of things. As to the state it's in, I mean, it's basically been in this disconnected state. I mean, I did replace the belts a long time ago. So the mechanism here, you can see there's one belt that goes all the way around the two capstans and the motor. So relatively easy to replace by taking the screws and this plate off. So that I did quite a long time ago. The last time I disassembled it, the mechanism was rather poor, sticking, and I lubricated all around here. Also underneath here there's an idler wheel which drives the forward and backward reels. That had started to reduce its friction, and unfortunately I hadn't realised this was the problem when a number of my cassette tapes were not playing properly, and I was thinking that it was the tapes. So I had a bunch of That's VX in particular, and they seemed to have slightly higher friction than some of the others, and they started to not play, and I just naively assumed that it was the tapes that had just degraded over time, so I basically threw them out. Only later did I discover that it was only the beginning, and really it was the take-up torque that was problematic. So the last time I did some servicing, I did roughen up the surface here of the idler wheel underneath this metal plate to give it some more friction. I don't think I fully tested it, so that may or may not be adequate. But I put some rubber renew on there as well, on the pinch rollers and so on as well. I mean, those pinch rollers seem reasonably serviceable still, not too much wear. Again, also the heads seem in pretty good nick considering. So it had a lot of use, kind of late 80s into the 90s, and then really not much at all after that. So in terms of total hours, not so much as you would expect for its age, perhaps. And then I had some other problems which I can't really remember what went wrong, why I didn't finish the repair. A bunch of these wires broke while I was sort of taking the mechanism in and out, and I then decided to remove everything and sort of remake them properly, and then never did. So I think basically I'm probably going to have to just put it together and see what problems I've got left, or which ones I've solved. I did just try it a minute ago, and the volume control on the record level here is a little bit noisy. I mean, it's marginal whether I should do anything about it, but while it's in this state, I probably will tried to get some more contact cleaner in there, because it's only going to get worse, I guess. Even though I'm unlikely to make many recordings, and even then, it's only really going to be a problem if you need to adjust it while you're recording. But still, why not for completeness? What else to tell you about this? The door. I mean, it's always been a bit kind of aggressive. So there was a phase in the 80s where like soft release mechanisms would be in fashion, and sometimes they'd even write them as a feature, soft eject, and sometimes they'd be so soft they would sort of really come out really slowly. This wasn't really one of those. It sort of clunked and really hit the end with a clatter. Obviously worse with a cassette in, and I spent a long time trying to soften this a bit more. There is a kind of roller. I don't know whether you can see. I mean, you can see the cog in there. Maybe that this part of the door has a tooth section on it, and that's a damper. That's a cylinder inside another cylinder with some oily, greasy material. And I tried changing that, putting bits of glue in there and bits of stuff mixed in with the greasy substance to try and increase the viscosity, and it never worked. I mean, it was either far too stiff, so it never opened this latch mechanism. As you can't really see it without the mechanism in, but it was either not enough, and then it would be okay, or it would be quite aggressive and still clatter at the end. So in the end, I found where the end stop of this is, and just put some silicone where it hits inside, and it just softens the end point slightly. Just a minor detail that probably nobody else really cares about. So I think that's what I'll do next. You've unfortunately the board is sort of connected. Let me come around. So you see the board is connected here and here with cables. So you've got to unscrew the front from the chassis, and the screw here, down there, and the one that is in the middle of these phono connectors, and then the whole board comes out with the front. That's what you've got to do, and then I forget how you get underneath this. I'll have to see how you disconnect this. So that's a bit of a job to get to this volume control, but yeah, I think I'll do that next, and then put the mechanism in, check that, and then there are plenty of calibration points, nicely marked also in the service manual, which I've got. So you've got calibrating the fluorescent meters, and playback calibration. I think that must be record level. No, this is record level. That is something else. I think that's frequency response. And then you've got these, which I think is the MPX filter frequency, and then the bias frequency if you need to adjust that. So and then of course the motor speed on the motor itself, with the traditional hole at the back of the motor for the speed. So there's a bunch of other calibration that I will need to do to try and get it into its top performance. So this is the circuit boards removed. You have to remove a couple of screws here for this circuit board here, which is attached to the main board with some captive wires, and then there are plastic clips here which are a little bit tricky to kind of remove because they sort of spring back, so you've got to put enough force on the circuit board in a particular way to stop them springing back without bending, breaking them, and usual kind of stuff. But with enough time and care and jiggling, you can remove them. So So yeah, basically on its side you've got access to, sometimes the dust will collect around here, so you can have a good clean. And what I'm going to do here is just spray a load of contact cleaner into this potentiometer here. That's the record level, just to reduce the noise when you move that. So yeah, simple job there. In the past I've also put some on these potentiometers and switches. Yep, that's it really. Here's the thing I didn't notice before. The electroluminescent display for the tape counter. I mean, it's huge. It's only got 4 digits when you see it through the little window there, but there's this section here that's blanked off, and yeah, it's hiding these other digits. Another 5 digits. So it looks very much like they just used a stock display from a calculator or something like that, maybe. Yeah, I can't believe I didn't notice that before. Alright, so I've put things back together again and wired up the rat's nest of cabling. I did initially connect up the motor backwards, it seems. So when I was trying fast wind, it would do the rewind and so on. So I just swapped those two cables over. You can actually fit the motor backwards, I think. Well, you turn it around, so basically the connections are swapped, so it's easy to do, and I just swap those wires to compensate. So it now sort of works. So let's put the tape in, and it does its thing. It does a little winding of the slack of the tape. That's what it does when you put the tape in, and you can see it's doing a brief bit of wind and rewind, but if you try to play, which it does for a few seconds, it then just stops. And that, now I remember, that was the fault that I stopped looking at and working on those few years ago. So yeah, that's something I will have to investigate and work out where to diagnose that. Is it part of the mechanism or the electronics or what? So yeah, that's my next point of investigation. So the mechanism on this deck is optoelectronic with this LED and photo transistor. I do remember when I had the mechanism open, there was a silvering and black section in segments around the reel for the take-up spool. So if this is situated such that you get reflections or not reflections off the silvering, that will send pulses along one of these lines, which ends up over here to some logic circuits here. So there's some parts of the circuit I need to check here. Are we getting those pulses from the sensor, or and it's failing to decode these properly here, some problem with this logic, or is it the sensor itself? Yeah, check on that connector. Maybe we're not getting those pulses right from the source. So I've got a meter hooked up to this connector here. The top 3 connections are well, the middle, the orange one here is ground, then the one in the middle, the red, is +5 volts going to the diode, and then the signal should be coming back on the top pin, the brown, which I'm monitoring here. So that is currently idling at 0.9 volts, but the thing is, it doesn't really change. This should be pulsing as the reel turns to show that it's not triggering an auto stop, but that's not changing. So yeah, that's why it's stopping. But there must be something wrong inside the mechanism. That photo diode unit must be iffy or somehow not working anyway. Oh dear. Right. Okay. Well, I'm going to have to take this mechanism apart again and try to get to it and see where that leads. Interestingly, on the service manual, you've got the color-coded wires here. So orange is the ground, and there's a weird thing where the ground goes down and round and then is connected here. But I think this diagram here for this device is wrong, because if you look, the red, which is definitely this one, which is the +5, that goes here to the phototransistor. It shouldn't. It should go to the diode. And similarly, the output here on the brown wire, that's going to the diode, and that should be going to the phototransistor. So that seems backwards. But anyway, I'm sure it was right from the factory. I'm sure it's just this diagram that's wrong. But yeah, just note that. That caused me a bit of confusion for a moment. Thinking about this a little more, I was measuring the 5-volt line, but of course that 5-volt is through this 220 ohm resistor. So if this was working properly and being a LED, you would expect it to drop quite a lot of voltage across this limiting resistor. And indeed, on the circuit, you've got a 1.2 volt there, so that would indeed show what we should be expecting to see on this connector. And I'm, as I say, I'm seeing 5 volts, so that would imply that this LED is not functioning. It must be open. And if we were to get a 1.2 volt drop, well, no, a drop to 1.2 volts here, that would correspond to about 17 milliamps, which is a reasonable value for an LED drive. So it does indeed look like that LED is not functioning anymore. So yeah, I'm going to have to take that mechanism apart and get to that. So while I'm here with the mechanism apart, I'm just going to put a bit of lubrication in a couple of places. So with some sewing machine oil on the end of this screwdriver, I'm just going to work a little tiny drop in the bearing and work it in like so, and then before I put it back together again, on these points here on the flywheels, where they touch these plastic points, I'll just put a bit of silicone grease, I think, just to hopefully help the wire and flutter figures. So unfortunately, in order to get at the circuit board, you have to take the real motor out, and that means getting at the real motor screws, which means taking off the mechanism here, the slidey head assembly, and various brackets and things and springs around this area. So at least now I can get at these screws here to remove the real motor. It did just show something that I'd forgotten I did a while back. So the plate, there's a plate that goes across here with a ball bearing, and it screws in here, but this plastic had started to split, so I had to put a bit of wire around here to give it some strength, hold it in, and then glue that in. So yeah, beware if you take this screw in and out a lot or over tighten it or something, then that's liable to split. So anyway, next step, remove the motor, access the circuit board, see what we can see, and then maybe test the diode and see if it's got any markings on, if you can get a replacement, etc. And here we are on the other side. You can see the circuit board. So 2 screws here. Let's get that out and see what we can diagnose on that. And that's the board out. Ridiculous board for just one component, but there it is, and it pokes through that hole there, which as the wheel turns, I don't know whether I can do that one-handed, but you can see it changes from silvered to black. Just about see there maybe. So that's what should be reflecting the light that comes out of one side of this and is received by the other. So let's see if I can give that a test, that diode a test. Alright, so I think I've discovered something interesting. So what have I got set up? Well, just a simple 5-volt power supply, and I'm driving, the intention is to drive the LED through this 220 ohm resistor, and then I want to see whether we get some light output. Well, of course, it's an infrared LED, so I'm not going to see it with my eyes. So I started to try to use the old trick of using the camera, because they tend to have a wider sensitivity, sometimes into the ultraviolet and into the infrared, so you could use that for testing like remote controls, infrared remote controls for your TV or whatever, and that would show a little flash on the camera, even though you couldn't see it with the naked eye. So I tried that on this phone, Galaxy S20 something or other, and I couldn't see any image. So I thought, okay, maybe the LED is indeed faulty as I suspect it. But then I thought, okay, well, I better double check my test methodology, because I've been caught out a few times with assuming my test is valid without a control. So I have some random infrared transmitter LEDs in my parts boxes. So I tried this one, which I assume is good. It looks like it's never been used, and I couldn't see it on this phone either. So then I'm thinking, oh, okay, well, maybe these new phones have some kind of filter or some kind of response which doesn't respond to infrared like the old phones do. So I got out this old Nexus 7 tablet with a pretty crappy, by today's standards, image sensor, and well, it's gone to sleep, so I need to turn it back on. So I've let me just reset the alright, so it's now propped up, as you can see, and so here is the receiver transmitter, and so I'm just going to turn on the power, and there you go. Look, you can see on and off that purpley light source. So that is showing that the LED is indeed working. But that is not even the most interesting thing, because I was thinking about the voltage I was seeing and the component tester, which was reporting a diode. This was on the pin here, which was the middle pin, which is brown, and that should be the output. So that should be the phototransistor. So no way should the phototransistor be generating light. So earlier on, I was thinking and commented that there seemed to be an inconsistency, and I assumed that it was this marking here that was wrong. But now I'm thinking, actually, this is correct, and it's this marking here that is incorrect. Right, so the brown actually shouldn't be brown, it should be red, and vice versa. These two are basically swapped. So that might explain why this went wrong. So last time I disassembled it, I doubt that I was very careful about noting which were the colours, because I knew I had this diagram. but didn't check it, of course, assumed it was corresponding to what the reality was. So it's very plausible to me to think I wired this up incorrectly the last time I assembled it, based on this incorrect color coding. So I think I am going to reassemble it now with these two wires swapped, and see what we get. I mean, I could wire up the sensor as well and see whether I get some response on the receiver. That might be possible, in fact. But yeah, that's my latest suspicion now. All right, back together again. So let's have a look at what it's doing, and well, voila, it's playing. So that was the problem. Last time I put it together again, I wired it up according to the service manual and not how it was out of the factory. Well, I never. So this has been faulty for years because of that. Amazing. Okay, so well, that's that done. I've obviously got sort of various calibrations to do, but I think I might end this video here and put those in a separate video. I'll leave it running for a bit just to sort of settle in the bearings and the oil and whatever, and then go through the calibration procedure. I think I'll do that yeah, a bit later. So anyway, thank you for watching, and yeah, I'm glad that finally got this mystery sorted out.